Have you ever wondered why huge lakes, like Lake of the Ducks, don't dry up like rainwater in your backyard? While a puddle in your garden quickly disappears, these lakes stay strong and full, year after year. It seems simple, but the answer has to do with geology, physics, and a bit of nature's luck. It's a combination of factors that makes all the difference. Some lakes, like Lake Baikal, are millions of years old. Imagine that. They already existed before we even dreamed of stepping foot here. How do they manage to hold so much water for so long? It's not just luck. There's a lot of science involved. The secret is at the bottom. Unlike your garden, the lake is like a natural basin, almost waterproof. The water can't escape easily. Layers of earth and rocks form barriers that don't let the water go away. These layers act like a protective shield. Let's dive into this mystery and understand how nature created these incredible reservoirs, which are true natural treasures. Get ready to discover the secrets that keep lakes alive for millennia. There's a lot of interesting stuff hidden underwater, from the Great Lakes in North America, which look like oceans because they're so big, to those small ponds in the countryside that help so many people every day. They all depend on these natural barriers to exist and not disappear over time. Let's uncover what's happening beneath the surface and finally understand this mystery of the waters that don't disappear. The lake bed is a true marvel of natural engineering. Over centuries, leaves, branches, and a bunch of tiny particles build up, forming layers of sediment. The weight of these layers compacts everything, creating a very dense mud that makes it hard for water to pass through. It's like a clogged coffee filter. The water passes slower and slower. This cushion of sediment can be meters thick and greatly reduces infiltration. Older lakes have even more sealed bottoms because nature has had time to reinforce this barrier. Even if it's not 100% waterproof, the amount of water that escapes is minimal. This process is continuous. The more time passes, the more efficient it becomes. But there's an even more powerful barrier right below. Let's meet the superhero of this story. If sediment is the first defense, clay is the impenetrable wall. Its tiny particles fit together so well that they barely leave any space for water to pass through. That's why clay has been used for millennia to hold liquids, and nature does the same in lakes. Depressions with a lot of clay form true natural basins. When water hits this layer, it simply stops, getting trapped like in a ceramic bowl. This way, lakes can accumulate water for thousands of years. And what if there's no clay? Don't worry, nature has another solution up its sleeve. Here comes the toughest barrier of all. If there's no clay, rock steps in. Many lakes form over massive rocks, like granite, which have almost no pores. Glaciers and tectonic plate movements carve out very deep depressions in these rocks. When the ice melts, water fills these basins, creating clear, deep lakes. Lake Baikal, for example, is in a tectonic rift and is over 1,600 meters deep. That's insane. The bedrock is an almost eternal foundation, very little infiltration, long life for the lake. Whether by glaciers or tectonics, the rock ensures that the water stays there for millennia. But it's not just a physical barrier that keeps the water in place. There's an invisible force lending a hand in this balance. Beyond the physical barriers, there's a powerful, yet invisible force that makes all the difference: hydrostatic pressure. It's always there, even if we don't notice it, acting silently and constantly on everything submerged. The weight of the water column presses down on the lake bed, further compacting the sediments and making it harder for water to pass into deeper layers. This effect is as if the water is always pushing downwards, making the lake bed denser and more resistant. This process connects directly with the water table, which acts like a huge underground water reservoir, storing and releasing water as conditions change. If the lake level is equal to or above the water table, the pressures balance out, creating a natural barrier that prevents water from quickly escaping into the subsoil. So, the water doesn't leak out quickly. It's like there's a constant tug-of-war between the forces pushing up and down, maintaining balance. In many cases, the lake is just the visible part of the water table, like the tip of an iceberg, while most of the water remains hidden beneath the surface. When it rains a lot, the water table can even feed the lake from below, causing the water to rise slowly and keeping the lake level stable even during periods of heavy rain. If the weather gets dry, the lake might lose a bit of water, but this process is very slow, as hydrostatic pressure continues to hold most of the water in place. This dynamic balance between water inflow and outflow stabilizes the lake level throughout the year, even with seasonal changes and climate variations. Even without a perfect physical barrier, the water doesn't just disappear overnight. The invisible force of hydrostatic pressure ensures the lake remains there, firm, resisting time and natural changes. Not every lake has a perfect bottom, and that's where slow infiltration comes in. When the bottom is uneven, with rocks, holes, or different types of soil, water finds unexpected ways to escape. Water leaks, but so slowly that it might take centuries for you to notice any difference. This process is almost invisible to the naked eye, but it's always happening, day after day. Sandy soils allow more infiltration because they have larger pores, but the sedimentation process continues strong, with particles being transported and deposited at the bottom. Tiny particles clog the soil pores, further reducing infiltration. Over time, this can even create a natural protective layer, making it even harder for water to pass through. Nature self-repairs. The leakage itself helps seal the bottom. This process is slow but efficient and keeps the lake functioning. The secret is the water balance. The water that comes in must be equal to or greater than the water that leaves. If this balance is maintained, the lake remains healthy. Evaporation, plant consumption, and infiltration are the main ways water leaves the lake, and they all happen at the same time. Rain, rivers, and the water table are the inflows. These sources replenish the water and help keep the lake level stable. As long as the balance is positive, the lake survives, even with small leaks. Small losses aren't a problem if there's enough replenishment, and that's where the water cycle comes in, which is our great friend, ensuring everything keeps working and that life around the lake thrives. If the lake loses water, why doesn't it dry up? Because it's always being refilled, my friend. The water cycle ensures constant renewal. Water evaporates, turns into clouds, rains, and returns to the lake. Rivers and streams act like hoses, bringing in fresh water all the time. Lake Victoria, for example, receives dozens of rivers daily. It's endless water. In rainy regions, the rain itself keeps the lakes full. Water enters through rivers and rain, and leaves through evaporation and the outlet, which is the outgoing river. Infiltration is just a small detail in this giant cycle. This continuous flow sustains entire ecosystems and keeps the lake alive. The secret is the combination of a good basin and a constant source of water. Today we learned that lakes don't disappear because they have layers of sediment, clay, and rock forming natural barriers. Water pressure and the balance with the water table help keep everything in place. Even with small leaks, the water cycle and water balance ensure the survival of lakes. We've learned to replicate these processes in dams using science and engineering. The story of a lake involves geology, physics, and biology in perfect harmony. Curious? Leave your questions in the comments and check out other videos on the channel. Thanks for watching, and see you next time.